Here are some more review questions for our last unit. In our last unit, we have some simple shapes and some weird shapes. So here's a weird shape. And this is a rectangle with a semicircle off the end. And it asks us for the perimeter. There's a pentagon on the inside. First thing, perimeter means the distance around, if you were to measure around the outside of the shape. So all of this for perimeter does not matter. If there was a line running diagonally, if there was a box drawn in here, if there was another half a circle, whatever, it's not on the outside. It's not part of the perimeter. We can forget about all of that. Next, I'm going to pick a spot. We're going to go around this first part here. That's 3, so this is also 3. This part here was my attempt at drawing half a circle. I'm going to have to figure that out. This is 3 here, and then 10 coming back. So the only thing I'm missing is that half a circle. So 3 meters plus half a circle plus 3 meters plus 10 meters will get us our perimeter. Half a circle, remember that a circle's perimeter is called the circumference. And that is 2 pi r, or we could say just pi d. Doesn't matter. It's the same. The diameter of this circle is from there to there, which is 10 meters. So I'll just use pi d because we have diameter given to us. Pi d, I'm going to use 3.14. Diameter is 10. It's 31.4. So now all I do is I take 3 meters plus 31.4 plus another 3 plus 10, and the total is 47.4 meters around this shape. So remember, just find all of the bits, 3 plus 31.4 plus 3 plus 10. Make sure you don't miss any. Some of them you might need to calculate. Here we've got a square. It tells us the area of the square, 256 square centimeters, and asks us for the perimeter. So first off, to get the area of a square, we could say length times width, or we could say base times height. They're the same as each other though. Any one side is the same as any other side in a square, so we often write it as side squared. So if we have 256 square centimeters is equal to s squared, I want to take the root of each side so that I can get just one side. And if I take the root of 256, that is 16 centimeters. So each of these sides is 16, 16, 16, and 16 centimeters. The perimeter is, again, we just start at a point. We say, okay, 16 plus 16 plus 16 plus 16. 16 plus 16 plus 16 plus 16. We could also write as 16 times 4, which is 64 centimeters. That's the perimeter of this square. So we take the area of a square, we take the root of it to get the side length, which is 16, and now we just add up 1, 2, 3, 4 of them. 16 plus 16 is 32, and another 16 and another 16 gets us to 64. Here we've got another with no picture given. A cylinder has a base with area of 706.5 square meters and a volume of 17,662.5 cubic meters. What's the height? It doesn't matter that it's a cylinder. It doesn't matter if it was a rectangular prism. It wouldn't matter if it was a triangular prism. Volume for all of these shapes follows the same formula, which is area of the base times height. We got area of the base. We want height. We're given volume. Solve for h. So I'm going to divide by area. Divide by area. Oops. That's what I mean. Divide by area, divide by area. Yeah, making sense now. Here, area and area can cancel. And now I've got volume over area equals height. We got the volume, 17662.5 cubic meters. We've got the area, 706.5 square meters. That should get us the height. 17662.5 divided by 706.5 is 25. Meters cubed divided by meters is meters to the 3 minus 2, which is just meters. Meters to the 1, one-dimensional. Let's do some more here. Here's a triangular prism, and we want the surface area, which means we need to know what parts there are. There are lots of different measurements here. This side, and this side are all different. It's scalene, which means that all of the rectangles wrapped around these triangles are different. There's a triangle here, and there will be a triangle in the back side here, if we were to draw the invisible part of this, that are going to be the same. So those two triangles will have the same area. Each of them has an area of base times height over 2. The base, let's just assume that this is a right angle, which I meant to draw in earlier. I just didn't. The base is 12. That's this. The height is 5. And each of them has an area of 12 times 5 over 2 of 30 square units. There's 2 of them. So I've got 30 for one triangle, 30 for the triangle in the back. I still need the rectangle on top. Rectangle on top. I still need the rectangle on the bottom. And I still need the rectangle that is back here on the left, I guess from our point of view here. Each of them has its own dimensions. So for the rectangle on top, the area is length times width, or base times height. And on top, those measurements are 13 by 18. So 13 by 18 is 234. On the bottom, on the bottom, we have another rectangle, and that is 12 by 18. By 18 is 216. And the rectangle on the left is 5 by 18. So area is length times width, which is 5 by 18. And 5 by 18 is 90. So now up here at the top, I've got all of the pieces of this triangular prism. 30 plus 30 plus 234 plus 216 plus 90, and I get a surface area of 600 square units. That's a nice number. These are all randomly selected numbers that I just made up here. And I got a nice 600 out of that. I feel good about it. Totally luck, but I can still feel good about it. Okay, one more question for this last review video. Which has the greatest volume? We've got 3 shapes, which we're going to assume all contain right angles. And you can tell by the great artwork that every angle in here is precisely 90 degrees. So for all of these shapes, its volume is area of the base times the height. Since they're all rectangles, you can say just length times width times height. It doesn't matter the order, because multiplication does not care about the order. So for our first one, 12 times 12 times 12 is 1,728 cubic meters, or cubic feet, or cubic I don't know what it is. For our second one, 24 times 8 times 9. It's the same. And for our last one, 2 times 54 times 16. It's the same. They look different. This is a classic stage of development thing here, where you like have a glass of water that's tall and skinny, or you have a glass of water that's short and fat. You fill them up with the same volume of water, the same number of milliliters of water, and at some point we start to learn that they could have the same amount even if this one looks like it's more full. There's a point in early childhood where you can pour them back and forth, and the child will tell you there's more in here and less in here, and then back and forth they'll say there's more water, less water, more water, less water. And there's a point where we start to recognize, hey, that's the same water. It's got to be the same amount. A fun thing to play with any young people in your life. See when they figure that out. Okay, that's all the review questions I want to do for this year. So that's all I'm going to do. I hope you do well on your test. Good luck to you all.